Hi there, and welcome to today's class. Today's class, we're looking at the concept of differential equation in calculus. So let's look at differential equation and also some basic concepts in the study of differential equation, which include the first order, the homogeneous, non-homogeneous, linear, nonlinear, and degree, and etc. So let's look at differential equation from start. What is a differential equation? By definition, the differential equation is an equation which contains at least one differential coefficient of an unknown function which gives a relationship between the dependent and the independent variable. This is the basic definition for differential equation. So we'll proceed further. So at this junction, we said a differential equation is an equation that contains at least one differential coefficient. By the word differential coefficient, what is a differential coefficient? Let me explain. So let's say for instance, let's apply our normal differentiation concept. Let's say for instance, I have that y is equal to s cubed. I'm asked to differentiate this man. What do? It's easy as the y over the x. So I'm differentiating y with respect to x. This gives you dy over the x is equal to, if I differentiate x cubed, that gives you 3x squared. This is my first derivative. Differentiate this man again. That gives you the squared y over the x squared, which is equal to, if I differentiate this man again, I'll have 6x. Differentiate this answer again, that gives you the cube y over the x cube, which is of course 6. So I'm saying this is my first derivative, second derivative, and what my third derivative. I had x cube as my question. When I differentiate it once, I have the order x, twice the square over x squared, thrice I have the cube y over the x cube. These ones here are called differential coefficients. A differential coefficient is simply the y over the x, or the squared y over the x squared, or the cube y over the x cube, or etc. Right? So note that these ones here are called differential coefficient. A differential coefficient is simply the y over the x, or the squared y over the x squared, or the cube y over the x cube, and etc. Please note these are called differential coefficients. At this junction here, we'll look at several terminology or basic terms we need to be familiar with in the study of differential equation. Something like first order, degree, homogeneous, linear, and then etc. So let's look at this term one after the other. So let's look at the basic terminology in the study of differential equation. So basic terminology. Let's look at the basic terminology in the study of differential equation. So the first one we're looking at is called the order of a differential equation. So the first one is called the order of a differential equation. Permit me, please. I'm calling DE differential equation. So let's start with the first concept called the order of a differential equation. What is the order, or what's the idea behind order of a differential equation? Put on, please. The order of a differential equation is equal to the highest differential coefficient involved in the differential equation. Now listen and listen. Let's explain order of differential equation. We said the order of a DE is simply the highest differential coefficient in the given equation. So I'm saying this, please. Let's say I have, we know now at this level, you should know what I mean by differential equation. differential coefficient, we mean dy over dx, or the squared y over the x squared, or the cube y over the x cube, or d to the power 4y over d to the power x to the power 4, and etc. These ones here are called differential coefficients. Now I'm saying that the order of a differential equation is simply a differential coefficient which have higher power. Let's assume now I'm asked to pick the order here. Order depends on coefficients, differential coefficients, which are all this. But which one is the highest? The highest here is this one, because it has power 4. The power here is 4, here is 4, so it's like the highest. So the highest so the highest differential coefficient in this case here is d to the power 4y over the x to the power 4. That's the concept. So I'm saying is that the order of a differential equation is simply the differential coefficient that has the highest power in a given expression. That's the concept. So let's take an example to explain order of a DE very well. Let's say I have an example of this nature. Let's say I have number 1. I have 2 dy over the x, then equal to 4y plus 3x. I'm asked to take the order. Number 1. Number 2, I'm given 4 d squared y over the x squared minus 2 into dy over the x plus 7 equal to 3y. I'm also asked to take the order in this case. First, for number 1 here, I'm asked to take the order. Is it first order, second order, third order, fourth order, or etc.? First start, you said order depends on differential coefficient. In this case here, I have only one variable coefficient here, which is what? The y over the x. Aside over the x, nothing else again. So this one here is the only differential coefficient I have here. What's the degree? What's the order in this case? The order is the highest. Where am I? Okay. So I'm saying that to get the order here, it's easy as your first task is to get the differential coefficient that is there. In this case, I only have one differential coefficient, which is divided by the x here. Now, what is the power of the differential coefficient? The power here is divided by the x. This is divided by the x, not the squared y. This is a square. This is like 1, 2, 3, 4. Here is just 1. So the order here, this is called a first order. So this is called first order. So when it comes to order of DE, it depends on the coefficient given. The coefficient here is divided by the x, right? The differential coefficient given is divided by the x here, and the power is 1. So my order is 1. Let's look at order here. We said to pick out order depends on the highest differential coefficient in the question, not just the differential equation, but what? The highest. In this case, I have 2 divided by the x, the squared y over the x squared. In between this and this, which one is the highest? Of course, this one is the highest. So, and what's the value there? Is 2 to the power of 2. So it means this expression here is a what? Is a second order differential equation. So I've got this, how you spot out the order of a differential equation. You said this involves the highest differential coefficient in an equation. In this case, there are 2, but I went for the highest, which is this one here. That is why this expression here is called second order of a differential equation. This is how you solve problem when it comes to order of a differential equation. Let's proceed to the next terminology called the degree of a differential equation. Number 2. Welcome back. So let's try to do second term called the degree of a differential equation. Number 2. Let's discuss the degree of a differential equation. All right. We have degree of differential equation. So let's define the concept behind degree of a differential equation. This is equal to the degree, the power or index to which the highest differential coefficient is being raised. I said this is equal to the degree, the power or index to which the highest differential coefficient is being raised. So if I have, so yes, I there. For degree of a differential equation, the idea boils down on your order. Order gives you the highest differential coefficient. So that highest differential coefficient, the power or the degree or the index is what there. It gives you the value of what? The degree of the differential equation. For instance, in this case here now, my order was second order. This was the highest differential coefficient. So how do I get the degree in this case now? The degree is simply what? The power to which this stuff is being raised, which is what? Invisible 1. So my degree in this equation now is what? Is just 1. Why 1? Because I'm focusing on what? The order. So your degree can be got. So you have to get the order first. The order gives you the highest differential coefficient in an equation, while the power to which the highest differential coefficient is being raised, it gives you what there? Gives you the degree. That gives you the degree, right? So let's solve some problem under this idea.
Can we do this again?
Let's proceed with some examples under this place. Example 1. So let's say some example. Number 1, I have f of t equal to dx over dt plus ax. I'm asked to find the order and the degree here. Number 2, g of t equal to the squared x over dt square plus a into the x over dt all to power 4 plus ax. All right, I have this, right? Number 3, I have mx equal to the squared y over the x square plus px. So what is the order and degree here? Number 4, I have n of x equal to the cube y over the x cube plus a naught into the y over the x to power 4 plus cx plus cx plus cx. What is the order, the degree? Yeah. First, for number 1, let's get the order and the degree. Let's get the order and degree. For number 1 here, if you observe closely that number 1 here, I have f of t equal to the s over the t, then ax. So I'm asked to find the order here. What I've been doing so far, I've been having the y over the x so far, so I can still have the y over the t. I can still have other variables. In this case here, I'm just having the y over the t. This is the only differential coefficient I'm having here. And this one here gives you first order. Let's get the degree. To get the degree, I'm focusing on my first order, which is my highest differential coefficient. What is the power? to which this is being raised. Here is 1, invisible 1. So the power here is degree. So this is degree. So the degree is simply the highest power to which the highest differential coefficient is being raised. The degree here is what? Is 1. So I have 1 first degree. Sorry, first degree. So this equation here is a first order equation and first degree equation. That's number 2. Number 2 here. Of course, I have the s over the t, the s over the t, no problem. First, to get the order, which one is the highest differential coefficient? The s over the t, the squared s over the t squared. This is the highest here. So the highest is simply the order. So this is second order. This is second order. Why second order? I'm picking this because this one here is not the highest differential coefficient. The highest differential coefficient is this one here, and is this. What is the degree to the highest differential coefficient? The degree here is super 1, right? Invisible 1. So this gives you first. That gives you a first degree. Permit me, D degree, right? So this equation is an equation that has second order and a first degree equation. Let's do number 3. For number 3 here, of course, I have only just one differential coefficient, which is what? The squared y over the s squared. The square of the s squared is second order. Second order. The degree is simply the power to which the highest differential coefficient is being raised, which is 2. That's second degree. Permit me, D is degree. Complete your own. All right. Finally, let's get this one here. Let's get order and degree. For this case here, the order is simply the cube y over the s cube. Why? Because it's simply the highest here. I have the y over the x. This is a linear. Sorry, this is not the highest. I still have the cube. This is the highest. So this is a third order, comma. The degree is simply the highest differential coefficient. This is 1, and first degree. All right. So this is how you solve problem. So this is how you spot out first order. This is how you spot out the order of a differential equation and degree of a differential equation. Let's proceed to other terminologies which involve the homogeneity of a differential equation. When I want to say a equation is a homogeneous or a non-homogeneous, let's look at the third one called the homogeneity of a differential equation. All right. So let's look at the third one there called the homogeneity. Before the third one there, you try this one for me. For the third one, you try this and leave your answer in the comment section. So try this one for me before we proceed to the third one. So try this for me. So your task is to try this. Tan squared 2x dy over dx plus sine x squared into the squared y over the x squared minus 4 sine inverse of 2x into the cube y over the s cube, right? All to power 4, like perhaps take this off. Into the cube y over the s cube, all to power 4, then equal to 5. All right. for this equation here, get me the order and degree. So for this expression here, give me the order. Is it a first order, second order, third order? Give me the degree. So get me the order and degree of this differential equation. So to get this one done for me, and leave your answer in the comment section. So let's look at the third one called the homogeneity. Number 3, homogeneity. Homogeneity of a differential equation. Let's look at the concept of homogeneity of a differential equation. A differential equation is said to be homogeneous if the equation is equal to 0 and a non-homogeneous if not equated to 0. A differential equation is said to be homogeneous if equated to 0 and a non-homogeneous if not equated to 0. So an equation, for instance, now this one here is not equal to 0. If it's equal to 0, it's said to be what there? It's said to be homogeneous. In this case now, this is what? A non-homogeneous. Why? It is not equal to 0. So the idea of homogeneity boils down on, that's a basic that's like basic level. I'm not saying generally, basic level. Note that the homogeneity depends on if it's equal to 0 or not. In this case here, this is what? A non-homogeneous equation. Why? Because this man is not equal to 0. That's the concept. So I said the homogeneity of an equation is said to be I said it is said to be homogeneous if it's equal to 0. So if it's equal to 0, it's homogeneous. If it's not equal to 0, it is a non-homogeneous. This one here is a non-homogeneous. Why? It's not equal to 0, it's equal to 5 here. That's your tax there. So let's look at the fourth terminology called linear and non-linear differential equation. The linear and non-linear differential equation. All right. Let's discuss linear and non-linear differential equation. Put on please. A differential equation is linear if the highest differential coefficient is raised to the power of 1. Else, it is non-linear. So here is the idea, please. When it comes to linear is when the power is 1. The power of what is 1? The power of the power of the degree. If degree is 1, so here's the idea. Your linear boils down on the degree. If degree, for instance, now this degree here is 1. This is a linear. If the degree and linear are like the same concept, you must get degree first before you can get linear. If the degree is 1, it is a linear. If the degree is more than 1, is what? Is a non-linear differential equation. In this case, check. This case here, the degree is 2, second degree. So the 2 there means it is non-linear. So this equation is what? Is a non-linear equation. Why? Because the degree is 2. So for you to get linear, check your degree. What's the value there? If it's 1, it is linear. If it is not 1, if it's above 1, then it's what? It's a non-linear differential equation. So let's take some question and see together how we can possibly solve that question using the idea of all these concepts. Take this down. So let's try example 1 here. So let's say I have example 1. So let's say I have this expression. I'm given the squared y over the x squared plus a into this one gives you, so this is cube the squared y over the x squared, yeah, plus a1y equals n into t. All right, I have this, please. Now, this equation here, I'm asked to state the order, the degree, homogeneity, and linear or non-linear. How do we get this done, please? The first one there is the order. Please, what is the order of this equation? We said the order depends on the highest differential coefficient in the equation. Check here, this is cube and cube, this is square and square. These two are the only differential equation that is here. Sorry, are the only differential coefficients that are here. The highest is this one here. And what's the value for the highest? Third. So this is what? This is a third order. Third order. Proceed, please. After order, move to degree. Please, degree still goes down to the highest order. What's the degree here? So if I take this in bracket now, what's the power here? That's 1. So this is what? A first degree. First degree. So like your order, degree, and linearity or linear concept, focus on once you go to your order, that thing that gives you your order gives you the degree and the linear. So I've gotten degree, order, and the degree. We say order because this is highest coefficient here. Degree is because if I take this, the part to which this is the part to which this stuff is being raised is 1. That's first degree. Second order, first degree. This man, is it homogeneous or non-homogeneous? We said homogeneity idea is if the equation is equal to 0. This equation here is equal to 0. No, equal to what? M of t. This is what? This is what? A non-homogeneous. This is what? A non-homogeneous. A non-homogeneous differential equation. Finally, let's get the linear. We said linearity goes down to degree. If degree is 1, then it's a linear. If degree is above 1, it's what? A non-linear. So in this case here, this is what? A linear differential equation. So this equation here is a third order, first degree, non-homogeneous, and linear differential equation. This is the idea behind the basic terminology involved in the study of differential equation. All right, in our next class, we're looking at the concept of solution of a differential equation much more later in our next video. So follow us to the study of differential equation. I also launched my WhatsApp group. So if you're interested in joining my WhatsApp group, check the video description. You see what WhatsApp group there. So in the WhatsApp group, I send the links of videos that are published to you in the group, and also you can reach me out to ask questions regarding this topic. So see you guys in the next class, and welcome to Excellent Link Academy.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.